students, welcome back to the series Coordination Chemistry. This is the second module and here we discuss nomenclature of coordination compounds. In the previous class, we have gone through the introductory part of the coordination chemistry, and in this module we will study about how to name a coordination compound. And a systematic procedure for naming the coordination compounds was developed by IUPAC, International Union for Pure and Applied Chemistry, and the naming of complexes are done using certain rules, and we have to follow these rules one by one to name a complex. First one, the number 1 is, if a complex contains anion and cation entities, cation is named first followed by the anion. So, when you are given a complex, whether it contains an anion or cation entity, you have to name the cation first. An example is given there, K4FeCN 6 times. It is an example, that is K4FeCN 6 times, and the complex contains two parts, that is anionic part and a cationic part. If we look at the complex, you can see that this K4 is the cationic part because potassium will form positive charge, +1 charge. So, +4 will be the charge of the 4K potassium ions. So, it is 4 plus. This is the cationic part. And now, the whole entity, that is the coordination sphere, will be the anionic part, that will be 4 minus. So, it is the anionic part. And according to this rule, what should be named first? Cationic part should be named first, and that is why the name is potassium. We will start with potassium because the cationic part is potassium, and the rest we can name according to the coming rules that will be explained in the coming slides. So, first thing you have to understand is the cationic part should be named first, and in the second example, it is AgNH3 twice Br. And in this complex, Br is having a charge of -1, that is a counter ion is bromide ion, it is having a charge of -1. So, this is the anionic part, and for the stability you have to add +1 charge to the complex ion. So, which is the cationic part? It is the complex ion part. So, according to this rule, which should be named first? Cationic part should be named first, and that is why the name starts with this complex ion, that is diamine, and how to name the coordination sphere will be discussed in the coming slides. So, first rule is, if you have a cationic and anionic part, the naming should be done first for the cationic part. Moving on, second rule is that naming the complex ion, it involves several steps. Complex ion is the ion which is in the coordination sphere. The whole thing in the coordination sphere is a complex ion, and while naming the complex ion, these are the steps to be followed. Number 1 is name the ligands first in the alphabetical order followed by the metal atom or ion. So, see, there is an example COSO4 NH3 5 times plus, and the whole thing is the coordination sphere which we have already discussed about the whole thing. And now, while naming this complex, what is to be followed? First, we have to name the ligands, and which are all the ligands present? This is sulfate ligand and ammonia ligand. Both the ligands are present, that is sulfate and ammonia ligands are present in the coordination sphere. And while naming this complex ion, we have to name the ligands first followed by the central metal ion, and while naming the ligands also you have to follow the alphabetical order. And when we look at the ligands, it is sulfato ligand, that is starting from S, and amine ligand, it is starting from A. So, according to the alphabetical order which should be named, we should start with A. So, we have to name ammonia ligand followed by the sulfate ligand, and that is why pentamine means how many ammonia ligands are there? There are 5. So, that is why it is penta, means 5. Pentamine means penta, 5 molecules of ammonia means pentamine, followed by the next ligand, that is sulfato, and then the central metal ion, that is cobalt 3 complex. This is the 3 is the oxidation state of central metal atom, and that will be discussed in the coming slides. Okay, and coming to the next rule. Name of the anionic ligands will end in O. We have already studied different types of ligands are there, anionic, cationic and neutral ligands are there. In the case of anionic ligands, the name should end in O. For example, chloride is an anionic ligand. It should end in chloro or chlorido. Both can be used. In the case of hydroxide, it is hydroxo. OH minus ligand is called hydroxide. It should be named as hydroxo. Sulfate should end in sulfato and nitrate as nitrato. So, the thing is the anionic ligand should end with O. And in the case of neutral ligands, common name of the molecule is used. For example, En is the neutral ligand. It is an example for a neutral ligand. It is ethylene diamine itself. While naming, you can use ethylene diamine as such. And some exceptions are there. See, H2O molecule, it is a neutral ligand, but it is named as aqua. It is named as aqua. NH3 is amine. It is also a neutral ligand. CO is carbonyl. CO is carbon monoxide, but the name is carbonyl. N2 is dinitrogen. Dinitrogen. O2 is dioxygen. And this is the way to name the ligands. And now coming to the cationic ligands. Cationic ligands means they are carrying a positive charge, and here while naming the cationic ligands, that should end in IUM. For example, NO plus, it is a cationic ligand, it should end in nitrosonium. And next C6H5NH3 plus, it is anilinium, and C7H7 plus, it is tropylium. So, all is ending in IUM. So, the cationic ligand should end in IUM. Anionic ligand should end in O. Neutral ligand should be named as such, and some exceptions are there. And now, di, tri, tetra, etc. are used to designate the number of each type of ligand in the complex ion. For example, if a ligand is appearing 5 times, it should be named with the penta. If it appears thrice, it is tri, like that. So, di, tri, tetra are to be used to designate the number of times each ligand is appearing in the complex. And if the ligand already contains the Greek prefixes, then we should add bis, tris, tetra, kis, etc. For example, if I take this ethylene diamine ligand, the name of the ligand itself contains a prefix, means di, ethylene diamine. So, while naming this ligand, we should add tris, because already it contains a prefix di, and then while naming we have to add tris. Okay. For example, if I take the complex CO, En thrice, SO4 thrice, the name should be tris ethylene diamine, because ethylene diamine already contains di, the name di in its name. And now, name the central metal atom after naming ligands. After naming whole ligands, we should go for the central metal atom. And if the complex ion is a cation, the metal is named as the element itself. For example, if the complex ion part means the entity which is written in the square bracket, and if that entity is carrying a positive charge, it is called a cationic complex. And in that case, that metal, that the central metal atom in the coordination sphere should be named as the element itself. For example, SO4 NH3 5 times plus. While naming this, you have to follow many rules which we have discussed earlier. That is, first we have to name the ligands according to the alphabetical order, sulfate and amine ligands. So, we should start with the amine, pentamine, sulfato, and then cobalt. So, cobalt should be named as such, because the complex ion is a cationic ion, cationic part. So, the central metal atom is named as such, that is why we are adding cobalt, and this is the oxidation state plus 3. And why we are adding ion here? Because in this case the plus charge is itself written. No counter ions are given in the example. That is why we are writing ion in the last part, this. Okay. And if the complex is an anion, name of the metal ends with the suffix ATE. This, the previous example we are explaining about the cationic complex. Now if the complex ion is an anion, then the metal, the central metal atom ends with the suffix ATE. For example, NiCl4 times 2 minus, this is a anionic complex. And while naming this, you have to follow first, you have to name the ligands first. And how many ligands are there? 4 chloride ligands are there. That is why tetra chloro, and central metal atom is nickel, and that should end in nickelate, ATE, and then followed by the oxidation state of the nickel, that is 2 plus. This is written here, and finally we have ion. Why it is ion is added? Because it is having a charge of 2 minus. And for an acid, if we are naming an acid, we should use IC at the end of the name. For example, H2PtCN 6 times. And while naming this complex, you know that there is a 6 cyanoligands there, and the central metal atom is platinum, and we have to follow the alphabet. One type of ligand is there, so no alphabetical order should be maintained. So how many cyanoligands? 6 cyanide ligands or cyanoligands are there. So hexacyano, and next we are going to the central metal atom, that is platinic. Why it is IC? Why we are adding IC? Because this is an acid. You know that this hydrogen is outside the coordination sphere, so it is an acid. That is why we have to add platinic 4 acid. 4 is the oxidation state of the central metal atom. And I have already discussed about how to calculate the oxidation state of the central metal atom. For example, this, if you look at the example of this complex, you know that the cyanide ligand is having a charge of -1, so it is -6. And the hydrogen is there outside, so hydrogen is having a +1 charge, and you have altogether +2 charge for hydrogen. For stabilizing, you have to give 2 minus charge to the coordination sphere. So this -6, how many cyanide ligands? 6 cyanide ligands, -6 to become -2. Then platinum should have the oxidation state of +4. That is why oxidation state of platinum is 4. That is why it is platinic 4 acid. Okay. And next, for a neutral complex, we have to follow certain rules. That is, the rules of naming the complex cation is used. Already we have discussed the rule for naming a cationic complex. That should be followed in the case of neutral complexes also. And for some metals, Latin names are used in the complex anion. That is, for example, we know that this iron, in the case of iron metal, it is ferrate. That is a Latin name. In the case of silver, it is argentate. It is, in the case of gold, that is Au, it is aurate. So argentate, aurate. These are the Latin names used. And now the oxidation state of the metal is given as a Roman numeral in parenthesis. For example, K4FeCN 6 times the complex. While naming the complex, we have to follow the rule, that is, if a cation and anion is given, we have to name cation first. That is why it is potassium first, potassium. Now name the anionic complex. While naming the complex, we have to name the ligands first, and number of ligands, that is 6. That is, so potassium hexacyano. Now we have iron as a central metal atom. Now it is ferrate, because iron should be named as ferrate, followed by the oxidation state of the central metal atom. It is 2 plus. That is why it should be written in square bracket, in Roman numeral. This is the Roman numeral. To the next rule, for the polynuclear complexes, we have bridging ligands which binds the 2 metal atom. Polynuclear means there are 2 metal centers. Poly means more than 2, more than 1. So, we have at least 2 metal centers. In the case, in those case, we have a bridging ligand, and the polynuclear complexes, the bridging ligands should be named according to the rules which are given below. They are separated from the rest of the complex by hyphen and then denoted by the prefix mu. This is mu. Okay. And it is repeated before naming each of the different kind of the bridging group. If we work out an example, it will be more clear. This is a bridged complex, or this OH, that is hydroxo ligands are the bridging ligands. And while naming the this bridged complex, what should be followed? See, which is the bridging ligand? Hydroxo ligand. How many bridging ligands are there? 2 bridging ligands. And what is the type of the bridging ligands? Both are same, that is hydroxo ligands. That is why, since there are 2 bridging ligands, both are same, di is used. Di, and there should be a hyphen as already mentioned, and then there should be a mu, that is mu should be included, and then we should name the bridged ligand, that is hydroxo. So, di mu hydroxo. Di means it has 2 OH ligands. So, it is di mu hydroxo. Next, coming to this part, see, if we are looking at both the sides, the same central metal atom and ligands are there. That is, cobalt is there, 5 amine molecules are there, and 1 chloro ligand is there. In this case also, cobalt, 5 ammonia ligands and 1 chloro ligand, chloride ligand. And that is why we have to add bis, because naming 1 is needed. Before that, you should add bis, because it appears twice. To denote the same thing is there, we can add bis. Bis, now we can name only one side, that is bis pentamine. Now, we have to name the ligands first, followed by the central metal ion, and while naming the ligands also, we have to follow the alphabetical order. 2 types of ligands are there, amine ligand and chloro ligand, and according to the alphabetical order, it should be A starting, amine is starting with A. So, amine should be named first, and pentamine, then next ligand chloro, cobalt, 3 ion. 3 means the oxidation state of the cobalt. Again, I repeat, this is a complex. The complex is a bridged complex. Complex contains 2 bridging ligands, and both the ligands are same, hydroxo ligand, and the hydroxo ligand, while naming the bridging complex, we have to add mu before each ligand. Since both the ligands are same, we have to add di mu hydroxo. And now we have to name each part, but in this each part, both the part is same. So, you have to name only one and just add bis before that, and that is why it is bis. Now, name only one part, that is bis pentamine chloro cobalt 3 ion. So, why it is ion? It is 2 plus charge. If it is a counter ion there, no need of ion. No need of adding ion while naming. Okay. Here are some of the examples of the bridged complexes, and you can name one by one. First example is CrNH3 5 times OH, CrNH3 5 times Cl5. In this complex, hydroxo ligand is the bridging ligand. Only one bridging ligand is there. And if we look at both sides of the bridged ligand, you can see the similarity or symmetry is there, that is CrNH3 5 times is there in both sides, and the coordination, outside the coordination sphere, there is a chloride ion. Now, while naming, what is the rule? Mu should be added before each bridging ligand. So, mu followed by a hyphen, mu, then what is the bridging ligand? It is hydroxo. So, mu hydroxo. Now, why bis is added? Because you have a symmetry, same type of central metal atom and ligand is there in the opposite, both sides. So, only one name one side only, and just before that you can give bis, and that is why bis. Now name one side, pentamine. How many ammonia molecules? 5. So bis pentamine, chromium, 3 chloride. 3 is the oxidation state of the central metal atom chromium. And the second example, that is CONH3 4 times, NH2OH, CONH3 4 times, the whole 4 plus. Here also you can see there is symmetry here and there, but the bridging ligands are different. One is amido, NH2 minus, and one is hydroxo. So we have to name one by one separately, and while naming them we have to follow the alphabetical order, and amido and hydroxo, according to the alphabetical order, we have to name first amido, and mu have to be included, mu have to be added previously. So mu amido hyphen mu hydroxo. Now we are coming to this part. It is tetramine hydroxo, tetramine dicobalt. Dicobalt means it is, there is 2 cobalt and 3 ion. Actually the name can be given like this also, mu amido, mu hydroxo, tetramine cobalt 3 ion. It can be like that. Okay. And now the third example is FeCO C5H5, CO FeCO C5H5. It can be named like this, the bridging ligand is CO, carbonyl ligand. Both are same, that is why we are adding di. 2 carbonyl ligands are there, di mu carbonyl, di mu carbonyl. Now here bis is added, why? There is a symmetry here and there, same central metal atom and same type of ligand is there on both sides. So bis carbonyl cyclopentadienyl ion, this is a cyclopentadienyl group. So the name is bis carbonyl cyclopentadienyl ion. This is the way to name this bridged complexes. Hope it is clear. Now for the ambidentate ligand, symbol of the donor atom is attached after naming of the group. If we have already discussed what is an ambidentate ligand. Ambidentate ligands will be containing 2 donor atoms, but one will be attached to the central metal atom at a time. And while naming them, we have to name the group followed by through which atom it is bonded. For example, if it is NO2 minus, NO2 minus means nitrito N. If it is ONO, nitrito O, or this ONO can be named as nitrito. Okay. And now the examples, some of the examples of naming the complexes are worked out here. See the example CrH2O 5 times Cl, Cl2. And now how can be named? This is a Cl2 means it is having an anionic part, that is 2 minus, the cationic part is 2 plus. If an anionic part and a cationic part arises, you have to name the cationic part first. So firstly naming the cationic part means the whole thing should be named first, and we have to follow the ligand should be named followed by the central metal ion, and the name is first 2 types of ligands are there, water or aqua ligand and chloro ligand. So aqua should be named first. How many aqua ligands are there? 5. That is why it is penta aqua, and 1 chloro, that is chloro, and which is the central metal atom? It is chromium, followed by the oxidation state. We have already discussed how to calculate the oxidation state. So the oxidation state should be added here, followed by the chloride. Chloride is the counter ion. And next case, it is K3FeCN 6 times. In this case, which is the cationic part? This is the cationic part. This is 3 plus and this is 3 minus. So cationic part is named, should be named first, that is potassium, and next we have to go here, that is the coordination part, the coordination sphere part, that is this, and while naming the coordination sphere part, name the ligands first, that is hexacyanoferrate 3. This is how to name. And now coming to the third example, FeCO 5 times. It is a neutral complex, so that we have to name first ligand. How many ligands are there? 5 carbonyl ligands. So, that is pentacarbonyl iron 0, because iron is having an oxidation state of 0. Carbonyl ligands are the neutral ligands of the, or they are having the charge 0. And now coming to the next example, CONH3 5 times CO3 Br. Again this is an anionic part, -1 charge, cationic part, +1 charge. First we have to name cationic part, and while naming, alphabetical order for the ligands to be followed. So, according to alphabetical order, it is amine, pentamine, followed by the next ligand, that is carbonato ligand. So, it is pentamine, carbonato, and you have central metal atom cobalt, followed by the oxidation state of the central metal atom, and then outside the sphere you have bromide. So, pentamine, carbonato, cobalt 3 bromide. And now next example we have PTEN thrice Br4. In this case, one thing you have to keep in mind is that ethylene diamine is having a di in its name. That is why we should add tris. So, before that, this is the anionic part 4 minus, Br is having a 4 minus charge on total. So, it is the cationic part is 4 plus. While naming the cationic part, which is the ligand ethylene diamine, it is tris ethylene diamine. How many ethylene diamine molecules are there? We have 3 ethylene diamine molecules. So, that is tris ethylene diamine, platinum. What is the oxidation state of platinum? It is +4 followed by bromine, that is bromide. And now here are other examples. First one is AgNH3 twice Cl. Again the cationic part is the coordination sphere part. It is the entity in the square bracket. First you have to name that. And how many ammonia molecules are there? 2. So, it is diamine, and the central metal atom is silver. It is diamine silver 1 chloride. 1 is the oxidation state of the silver. And coming to the next example, you have COEN twice Cl2 Cl. Cationic part is the complex ion part, and while naming you have to follow the alphabetical order rule. It is first chloro and ethylene diamine, which should be first named. It is chloro. That is how many chloride ions are there? We have 2. So, it is dichloro or chlorido. We can name chloro or chlorido. Here dichloro or chlorido, then bis. Why bis? Because we have ethylene diamine as a ligand here. So, we are adding bis ethylene diamine cobalt 3 chloride. 3 is the oxidation state of cobalt. And now third example is CuNH3 4 times SO4. Central metal atom is copper, and you have the cationic part as the complex ion part, because sulphate is outside the coordination sphere. Sulphato ligand or sulphate ligand SO4 is having a 2 minus charge, and that is why it is a 2 minus, having a 2 minus charge, 2 minus. So, it is 2 plus here, 2 plus here, and name the cationic part, that is the coordination sphere part. First we how many amine ligands? It is 4. So, tetramine copper, copper is having an oxidation state of +2. So, it is tetramine copper 2. Outside the coordination sphere it is sulphate ligand. So, it is just sulphate. And now coming to the fourth example, CO3 NH3 4 times Cl. While naming, the cationic part is the complex ion part itself, and we have carbonato ligand and amine ligand. So, first name amine ligand according to the alphabetical order. So, tetramine, carbonato, cobalt, oxidation state is +3, and then chloride. Another example, CrNH3 thrice H2O thrice Cl3. In this case also the complex ion part is it is having a plus cationic part. So, the cationic part should be named first, and according to the alphabetical order amine should be included first. So, triamine, how many water molecules? Tri, that is 3 water molecules. So, triamine, triaqua, chromium 3. 3 is the oxidation state of chromium chloride. And sixth example, K3FeCN 5 times NO. Here the case is different, that is you have the cationic part outside and the anionic part is the complex ion part. So, first we have to name the cationic, that is potassium, followed by the anionic part. Anionic part, you have two ligands present, it is cyano ligand and nitrosyl ligand, and cyano and nitrosyl means we have to name cyano first. So, potassium pentacyano, 5 cyano ligands are there. So, potassium pentacyano nitrosyl ferrate, because it is iron is a central metal atom, followed by the central metal, the oxidation state of central metal atom is +2, that is why 2. And now coming to the next example, it is Na2NiEDTA, Na2NiEDTA, which is the complex, which is the cationic part, it is Na, sodium, and the coordination sphere is having an anionic part. So, first we have to name the cationic, that is sodium, and now it is the naming of ligand is like this. EDTA should be named as 2, 2 dash, 2 double dash, 2 triple dash, ethane 1, 2 dilido nitrilo tetra aceto nickelate 2. You have to study this, how to name the EDTA complex like this, and then followed by the central metal atom, that is nickel. It should end in ATE. So, nickelate followed by the oxidation state of the central metal atom. And the final example, it is palladium PdI2 ONO twice H2O twice. This is a neutral complex because no charge is there, and we have to follow the alphabetical order. We have aqua, that is H2O ligand, ONO, that is nitrito ligand, iodine ligand. So, first name should be given for aqua, that is why how many H2O molecule we have 2. So, diaqua. Next iodine and nitrito, which should be named, it is iodine, that is why diaqua, diiodo, dinitrito, palladium 4, that 4 is the oxidation state of palladium. And now another example, CrPPH3 thrice CO 5 times. Again this is a neutral complex, that is it is not having any charge. So, the ligands are PPH3 thrice triphenyl phosphine ligand. PPH3 thrice means triphenyl phosphine, and carbonyl, CO means carbonyl ligand, and triphenyl phosphine and carbonyl, it is carbonyl. That should be named first. So, pentacarbonyl triphenyl phosphine chromium 0, because chromium is having an oxidation state of 0, because both the ligands are neutral ligands, or they are having a charge 0, that is why chromium is having an oxidation state of 0. And now coming to another example, CONO2 thrice NH3 thrice. It is very easy to work out. And now coming to the here this example, that is CONH3 4 times Cl2 the whole thrice CrCN thrice. How to name that? First we have to name this complex, that is CONH3 4 times Cl2 the whole thrice, and here the alphabetical order it should be first named. NH3 should be named first, tetramine dichlorodo or chloro, dichloro cobalt 3, and next hexacyanido means it contains cyano or cyanido can be used. Hexacyano means it contains 6 cyano ligands, hexacyano chromate 3. And now another example, AgNH3 twice plus, it is very easy to name, that is diamine silver 1 ion. Why ion? Because it is a plus charge there. Like that you can name the complexes by following these IUPAC rules, and it is very easy to study the rules. And in this class we have discussed about the several rules of coordination, naming the coordination compounds, which was introduced by IUPAC, and all these rules are very important to study, because it is to name a complex, it is very necessary to know the rules one by one, and you have to follow these rules accordingly. Thank you for watching this module, and in the next module we will be discussing about the isomerism of coordination compounds. Thank you.